So relationships between angles, X and Y values on the unit circle. So I'm going to try to draw a good circle again. All right. And then this is going to be the unit circle. So let's put some axes in here. Good enough. And if that's the unit circle, then this up here is y equals 1. Over here would be x equals 1. Down here would be y equals -1. And over here would be x equals -1. And then I just want to pick some angle, that one right there. And I'm just going to call that angle right there theta. Now theta here leads to this point on the unit circle. And that right there is a radius of 1, right, on the unit circle. This point has coordinates x and y. And as I change this angle, the x value is going to change. And as I change this angle, the y value is going to change. So what I know here is as I change the angle, x and y change. So that means x is a function of the angle and y is a function of the angle. So x is a function of theta. Right, and that in mathematical notation, we might say that x equals f of theta. Now we're used to writing y equals f of x, but the variables can be anything we want. In this case, x is the x value on the point in the unit circle, and theta is the angle measured from the positive x-axis to the radius. Now, the x value is different from the y value at most points. Okay, so as we saw earlier, if theta was pi over 6, then x was the square root of 3 over 2. Y was 1/2. If I pick the angle 0, x is going to be 1, right? So I can make a table here for x values or theta values. That's my independent variable, and x is my dependent variable. So for example, when theta is 0, x is 1. When theta is pi over 6, we figured out earlier, or 30 degrees, then x was the square root of 3 over 2. If theta happens to be pi over 2, a 90-degree angle, then x is going to be 0, right? So at pi over 2, 90 degrees, x is going to be 0, right? A function is when you have some input and it forces some output. So the question is, how do we calculate the x values given the angle? And it turns out, well, I showed one trick for one of them over here. There's infinitely many possible angles. And this function is very special, and it's given a name, and that name is called the cosine function. Cosine function is abbreviated COS. So here, the x value on a unit circle is equal to the cosine COS of parentheses the angle theta. You really should use the parentheses. Some books skip the parentheses and you might just see just cosine theta. That's extremely bad notation. Always use parentheses because it is a function of the angle. It's not a multiplication. It's not a word. It's a special function. And so we can look at that on a calculator. We'll do that in just a second. So that's the x value here. Now the y value also changes when the angle changes. So if I made a table over here for the y value as the output and the angle as the input, starting over here at this point when the angle is 0, the y value, right, we haven't gone up or down, that's 0 also. If we get out to pi over 6, which we did earlier, we found the y value is 1/2. If we go all the way up, sweeping an angle of pi over 2 to get that right angle right there, then we would find the y value would be 1. If we kept going, like over here, we had 5 pi over 6 on the other page. So 5 pi over 6, the y value would be still 1/2, right? So as the angle changes, the y value changes, and it turns out that function, y is a function of theta. That function has a special name that is called the sine function. And we abbreviate that just SIN. So we'll see y equals the sine of theta often, where theta is the angle measured in standard position here. So this point xy can also be called the point cosine of theta to get the x, sine of theta to get the y. And so these are very special trig functions, the two most important trigonometric functions, and we're just going to play around with them some more. For the rest of the quarter,